Alrighty, we'll try this again without Skynet. Alright, so looking at this, we have, it says, I know why, because it's been sitting on the power button. I just realized that. So, because the power button's on the side. And so when I put it in there. Alright, anyway, area of polar coordinates. So this is actually kind of neat. Anyway, we don't have to do this one here. But it's in the notes just in case, you know, you're feeling froggy, you want to learn some math. Okay, area. So the area of a slice is in radians 1/2 r squared theta. Yeah. Okay. Blah blah blah. So we're actually finding it of whatever function because this is going to be the polar coordinates, so therefore it's going to be like, you know, little circles around or stuff like that. Okay. There's the formula that we need. From A to B, so A from alpha to beta, which is some angle to angle. So find the area of the region by the cardioid. R equals 1 sine theta, and it's going to be between 0 and pi over 2. So if I'm writing out my function, it's going to be, or my equation, it's going to be integral from 0 pi over 2. What goes next?
The 1/2 r squared.
1/2 r squared. So it is 1/2. What is my r?
1 minus sine theta.
Squared and d theta. So let's go ahead and take that 1/2 out and then expand my 1 minus sine theta. So it's going to be 1/2 integral 0 pi over 2, and that's going to be 1 minus 2 sine theta plus sine squared theta d theta. And this thing is not going to be pretty because that sine squared, what would we normally do if I saw a sine squared? Yeah, change it. I'm going to change it, but then isn't that like a chain rule type thing, right? Yeah. So whenever we see a chain, we try and do a u sub. Yeah. But in this one, it's not really going to work out as a u sub. Okay, because when I u sub, I'm going to get a cosine, right? And then that cosine would have to go back in there to take away something else, and it's really not going to cancel out very well. So I could actually use other identities. So a trig identity that could actually go from a sine squared to a 2 theta. There's a couple of them, right? Okay, so let's go ahead and use that one. So what is sine squared the same as? What is it? Sine squared theta is equal to, or actually, let's look at the double angle first. So it's going to be, you want cosine 2 theta? Try to help them out.
Yeah. 1 minus 2 sine theta.
1 minus 2 sine squared theta, right?
Yeah.
That's the double angle identity, right?
Mm-hmm.
So I'm going to use the double angle identity, and I'm going to isolate for what?
Sine squared.
Yeah, I'm going to get sine squared by itself, so I could actually use that. Okay, so subtract 1, right, and then divide by -2. So if I subtract 1, it's going to be -1, but if I divide by -2, that's going to be +1, right? 1. Did I lose you guys? And speak now or forever hold your peace. Okay, so I'm going to replace my sine squared with 1 minus cosine 2 theta over 2.
And you can use sub for cosine.
Just for the 2 theta, right?
Well,
Yeah, just for the 2 theta. So that I could do that part easier. Okay, so I'm going to replace that. So let's take a look. So I'm going to take it to the next page, I think. Yeah, so I have the 1/2 integral 0 pi over 2, and it's going to be 1, was it minus 2 sine theta, right? And then it's going to be plus 1 minus
cosine 2 theta.
cosine 2 theta over 2, and then it's d theta. Okay, so how about that 1 minus and then all that over 2, right? Could I just change that to 1/2 minus cosine 2 theta over 2?
Yeah.
Okay, so let's change that. So just rearranging things to make life a little bit easier. 0 pi over 2, 1 minus 2 sine theta plus 1/2 minus cosine of 2 theta over 2. Too big. And then d theta. So what we're actually trying to find here is the area, because we're starting here, right? That's going to be 0, and it's going from here to here, which is pi over 2. We're just trying to find that. Okay? All right, so let's go through and we can do the integration now, right? And let's turn this into 3/2. That 1 plus 1/2 is 3/2, right?
Yeah.
Yes?
Yep.
Okay, so 1/2 bracket 3/2 x, right? Because I combine this and this to 3 over 2. Yeah?
It's still an integration.
Yes, it is integration,
Oh
right?
wait, you put the x.
Yeah, I got an x there now. Okay, so it's going to be,
Theta?
huh? Oh, yes, you're right. You're right. Thank you. Should be a theta. Good job. All right, so we got theta.
Candy points.
Hey, I know, right? Yes, if I had candy, I'll throw it at you. I'll find some. All right. Okay, so integration of -2 sine.
Plus 2 cosine.
Plus 2 cosine, right? Do I need to draw the wheel?
No.
Okay. All right, so plus 2 cosine, and I could u sub this on the inside, right? So if I u sub that, it's going to be 1/2 du for that piece, right? So wouldn't that just change that into 1/4? Do you guys want me to do all the steps? Yes? Okay. So if 2 theta equals u, I'm going to have du is 2d theta, right? Divided by 2, 1/2, and then I would just take the integration of cosine by itself, right? And that 1/2 turns this into 1/4, doesn't it? Okay, so what is going to be the integration of negative cosine? Negative sine. So it's negative sine over 4, right? And that's going to be my 2 theta again. Put it back in there, right? And that's from 0 pi over 2. Okay. Are we okay still?
Yep.
We okay? So if I said something funky, let me know. All right, let's go ahead and start plugging stuff in. So this is gonna give me 3 pi over 4. So 1/2 bracket 3 pi over 4. And so cosine at pi over 2 is 0. So that's plus 0, right? And so this is going to be 2 times
So it's going to be 2 times pi over 2, which is just pi. So
pi. Sine at pi is
0.
0. Okay, so there's the top minus the bottom bound. So that's going to give me 0 for the first one, right? Cosine at 0 is 1 times 2 plus 2. And then 0 times 2, 0. Sine at 0 is, right? Okay. So let's see, that's going to be -2. But then as I distribute this, it's going to be 3 pi over 8 minus 1. Okay, so now what if I wanted to approximate that? Throw that bad boy in your calculator, let's see what we get.
.178.
0.178. Everyone else?
Yeah.
Okay. It's going to be really small, isn't it?
Yeah.
So you could actually check to see what type of answers you should have. Because you could do, let's see. All right, so I'm just hypothetical here so you guys could actually have a realistic type of thing. So I know this is a circle with a radius of 1, right?
Yeah.
I know, I tried. It's kind of, you know, the projector, I was like in my own shadow. Anyway, all right, so that's a circle with the radius 1, right?
Yeah.
So the area of that circle that I'm only using is like a quarter of that, right? So I know that the area is supposed to be
1/2. Well, it's the 1/2. If we're looking for like the little slice, 1/2 r squared theta.
yeah, one that's of the slice though, right?
Right.
Well, what is
You want
the
the whole
area of a circle in radians?
Yeah.
Pi r squared. Pi r squared, right? But now, how much of that am I using? Let's say it's less than a fourth, isn't it? Because it's only going to be from here to here.
Yeah.
So you guys could actually have a good understanding, say, all right, practical amounts that I could have. So I was going over some problems with my Calc 1 earlier, and they got some like ridiculous answers. I'm like, all right, is it too much, or is it you know, not enough, or how what reference do you have to see if it's going to be too much? So this would be of 1/4 of whatever that is, right? So it should be 1/4 pi. So it should be less than that. So an actual answer, what answers could be, should be something like that. That's how you could figure out, okay, hey, look, is it too much or is it not enough? Anyway. All right, so find the area enclosed by the cardioid. R equals 1 minus sine theta. Okay. So if it's enclosed by that, what does that mean? It's enclosed by that. Isn't that a shape? What's the shape?
Closed figure.
There you go, right there. Go ahead, go ahead.
Okay, a heart.
Yes,
Yes.
it's kind of like a heart, right?
Yeah.
Yeah, so it's kind of like a fat heart. So it is going to be like that, okay? It's going to be like that. So it's the whole thing. Now, how long do you think it takes for this to make a whole shape?
0 to 2.
0 to 2 pi, all right. So we know that we're going to start off with integration, 0, 2 pi, right?
Yes.
Okay, so what else do we have to add here?
1
1/2
half. I think we just start with that outside. R squared.
r squared, right? So it's going to be 1 minus
Sine theta.
sine theta
That's square.
squared. Anything else? d theta. Okay. Really similar to what we just did, right? Okay, so,
Wow, really smart.
yeah.
Just take the integral from the last and then put the bounds in?
Are you saying to take the integral from the last one and then just change my bounds?
Yes.
Wouldn't that be really, really quick?
Yes.
Okay, so
Let's
yeah.
do it that way.
So you're saying that we're gonna have 1/2, right? Okay, so I'm gonna rewrite my integral first though. Okay, just for the YouTube land. To pi, right? And that's gonna be 1 minus 2 sine theta plus sine squared theta, right? And that's d theta. So go back through what we did previously. So it's gonna end up 1/2. Okay, all my integration. So I'm bringing it back in for my last one, right? So it was 3 over 2, right?
Yeah, 3 over 2 squared.
3 over 2 theta.
And
What went next?
Plus 2 cosine theta
2 cosine theta
minus sine 2 theta over 4.
sine 2 theta over 4. And my bounds are 0, 2 pi. All right, do it.
3 pi.
What did we come up with? Give me an actual answer, not decimal.
I don't know, it might be wrong. 3 pi halves.
Yep.
Yeah, okay, I got that too.
Okay.
Sounds like a fun number.
Find the area A enclosed by the graph of r equals 2 cosine 3 theta. Okay, so this arose with 3 petals. Okay. So, let's take a look at my... I can't even click on it here. Gotta fix my screen again. Anyway, my calculator is not up. So alright, so right now I want you guys to change your calculators. I want you guys to try and enter that into the graph so we can see what we're doing. And I'm gonna do it on the big screen here in a second. So make sure you change your settings. My trig classes were working in other means. Alright, so let's see what I got. So let's go ahead. Right here I have function. Let's menu, enter. We are polar. R equals, was it 2 cosine?
Yeah.
Cosine of 3 theta.
Yes.
And this is going to be from 0 to 2 pi. There we go. Now, since I have this right here, now I got a slight issue. Where does my graph start? Where's my graph always start? 0, thank you. So it starts at 0. But now I also have to try and see where is this next one going to be equal here. Okay, because I have a pedal of this right here. So what I'm going to do is menu. Let me zoom this a little bit better. So what I'm going to do is, dang it,
Yeah.
is mess up.
Oh, there she is.
That's no move.
There we go. All right, so let me escape. There we go. All right, so what I'm going to do is, because I have to try and figure out my pedal, my first pedal starts at 0. So that's going to be one of my big issues. So I start here, and I go all the way to right here. So if I could find the area of this piece right here, what can I do to help me with the rest of this?
Multiply it by 6.
Multiply by 6. Because otherwise I would have to try and do an interval from a negative, right? So I don't really want to try and do that. I want to start at 0 and I want to go to here. So 0 to here. So I need to figure out where is this one also going to be equal to 0 at. So let's see.
It's where cosine of 3 pi equals cosine of pi halves.
So let's see. So I know, because I want this to equal 0. So let's say 0 equals my 2 cosine of 3 theta, right? So divide by 2, so 0 equals cosine of 3 theta. So let's see, that's going to be, so 3 theta is equal to arc cosine of 0. What is arc cosine at 0?
Pi halves.
Yeah.
So it's going to pi halves. So we get pi over 2 is equal to 3 theta, right? So it's not the only place, but that's one place, right?
Yeah, that's the closest place.
Yeah, that's the closest place for what I'm going to do. And then divide both sides by 3. So I should get theta should be pi over 6. So I've set that up now so I could actually go through and do this every single time. So I could just keep going around. So let's go through and look at my integral now. My integral is going to be from 0 pi over 6. And what else do I add to that?
Well, 6 times X.
6 times, because I'm going to have 6 of those parts, right? So 6 of those, then it's going to be 1/2 of my 2 cosine 3 theta, right? Squared d theta.
Wait, how do you know if it's gonna be 6?
Okay, so going back to the graph. So it has 3 petals, right? So it even says it in the problem that it has 3 petals. And that's going to be your part that's going to help you on this. So if it has 3 petals, that means that I'm going to get this one and start at right here. So I'm going to start at 0 and go to right here. So since that is going to be the top piece right here, and if I times it by 2, that would be that whole petal, right? But if I times it by 6, it would be these two, and these 2 here, right? So it's the top half and the bottom half together. So that's why it's going to be times 6, because I'm just finding the area from 0 to, I'm sorry, from just the top part, from 0 to pi over 6 right here. Now, if it was a sine function, where does sine function start at? Sine starts at, say, 0. And cosine starts at 1, doesn't it?
Yes.
Okay, so that's going to be important. So I'm going to go back to my thing to show you the differences.
It would be shifted up.
Yeah, the whole thing would be shifted, wouldn't it? So wrong one. Sorry. So the whole thing would be shifted. So my petal, so on my graph it would look like this. So my petal would start here and go like that. So it would start at 0. So on this one, if it was a sine function, I would just do 3 times, right? Because sine starts at 0, so I could do my whole petal, this whole thing right here. I could do the whole one, and then multiply by 3. Yes? But since this one starts at cosine, and it's halfway in the petal, right? From 0 to here, it's going to give me halfway in the petal.
So then if it's close in, then it will always kind of like
It should be
double?
6. Yeah. Depends on how many petals. So since this one is 3 petals, it's going to be like that.
Could you change the function from cosine to sine and then get the same area? Would it give you the same area? And then you could do it that way instead of,
Cosine to...
and then do 2 sine for theta, and then would that give you the same area? And then you could do it that way.
I don't think so. Maybe. I don't know. That'd be a good thing, do the math on. Anyway, let's just go with what we have here. All right, so going through the problem. Okay, take that out. So it's going to be, I'm going to have 3 integration 0 pi over 6, and that's going to be 4. And that's going to be cosine of squared of 3 theta d theta. Again, I have that square, right? Okay, so since it's a square, I'm going to use a double angle to try and replace that. But then when I do a double angle on that 3 theta, it's going to become... What's double 3 theta? It'd be a 6 theta, right? It'd be a 6 theta. So I want you guys to try that one right now, please. So we're doing the same thing, but now this time we're subbing. So we're getting rid of the square. We're getting rid of the square by using the identity of the double angle. But my double angle is not going to be 3 theta or 2 theta. You're doubling the angle that we have, which is 3 theta. Is that what you guys got?
Is that the identity for cosine squared or sine squared?
Yeah, that is exactly.
It's the same?
Oh, that's a cosine, right? No! Crap,
Yeah.
I need a plus
It should
sign.
be plus.
Yeah, it should be a plus.
Side,
Yeah.
and
That's
then
all.
also
Ah.
multiplied by
Okay, so it's gonna be
That's
1 plus?
One
Yes.
cosine, did you do?
There should be multiplied.
Yeah, 1 plus
It's the
cosine,
same thing,
or,
just
well, I did
different
cosine
signs.
6 theta plus 1 over 2, but you know, whatever.
1 plus cosine 6 theta over 2 d theta. You could have changed it into a sine also.
Yeah, I didn't really want to do it.
It could have been a sine.
Oh, you pulled out the 4. That's why.
Yeah, the 4 came out. Bracket 1/2 theta.
Well, yeah, 'cause the 6 is
That works very. Because then the cross section becomes pi. Becomes 0 and 0. That's cool how the trig function is just disappear.
So what's that gonna be? Pi over 12 times 12, which is just pi?
All that.
They know stuff.
Yeah.
I know.
Wow.
Alright, I think that one's it for this. We're gonna do the rest tomorrow, yeah. Okay, so, like, share, and subscribe.